area of cross section is circular, then it will be circular. If it is square, it will be square. If it is rectangular, then it will be, you can say it will be rectangular. So ultimately die is the important thing. If what is the quality of die, what is the different size, shapes, and different parameters of that die, accordingly the material or accordingly the output of material will be there. So whenever you are manufacturing the things with the help of this extrusion, it is very important that die should have a very high quality. It should not erode with time, because when you are in a process of mass producing something and you are using again and again that particular type of die, then it should be it is very important that die should have high quality, so that the material which is being manufactured should be of same quality again and again. And secondly, the die should not erode, or die should not, you can say, deteriorate with the time. Now these are the uh, some of the shapes or different materials, some of the different uh, configurations that can be used, that can be manufactured with the help of this extrusion shapes. The die, basically it depends upon the what type of die we have used. First is the circular one, then we have this hexagonal one, then we have hemispherical, spherical, L shaped, I shaped, or suppline type of you can say structure and shape, square, then these hollow type which are hollow in the center, like circular shape, this ring shaped, square shaped, D shaped. So different shapes can be given. So it depends upon the die, I can say. So how you manufacture die, how, what is the shape, what is the size of that die, how you push it, and then accordingly you can say that manufacturing can be there. So different methods are there, you can say, of manufacturing. We can use different methods, like machining is another method. These things can also be manufactured with the help of machining also. Now but what we do basically in machining is that we have different machines like lathe machine, milling machine, shaper, planer, drilling. So these different machines are, you can say, are applied on the workpiece in a set of different sequences, so that the material, the, you can say that the material will not deteriorate, and ultimately the uh, the material will not deteriorate, and ultimately the product will be manufactured accordingly. uh, the material itself is very you can say dependent upon the type of structure, type of input variables which we are taking. So and accordingly you can manufacture. So each product can be manufactured by different routes. It can be with the help of extrusion process, it can be manufactured with the help of some machining process, it can be manufactured by rolling or shaping or anything. But but it, it is very important that which route should be followed and why, because the industry, as a engineer in a industry, you must be familiar that the product quality should be according to the requirements, first thing. Second, the the manufacturing method should not be very cumbersome or difficult, its capital cost should be very low, and you can say its usability or its workability should be very easy. So accordingly you can use it. Now under this extrusion processes we have different processes, you can say. uh, first one first one is the, you can say, hot extrusion process, in which it is a hot working process in which it is done above the materials recrystallization temperature to keep the material from work hardening and to make it is easier to push the material through a die. Now hot extrusion under this topic, ultimately we have two topics. First is the direct extrusion and second is the indirect extrusion. Now this is the diagram for a direct extrusion. You can see the schematic diagram of direct extrusion has been shown. Now in this direct extrusion, also known as forward extrusion, is the most common type of method of extrusion, in which it works by placing the billet in a heavy walled container. The billet is pushed through the die by a ram or a screw, and there is a reusable dummy block between the ram and the billet to keep them separated. The major disadvantage of this process is that the force required to extrude the billet is greater than the needed in the indirect extrusion process because of the frictional forces introduced by need of the billet to travel the entire length of the container. Now you can well see uh, that in this process we have two containers. One is up above this billet and second is below this billet, and on left hand side we have a ram that is used to push that material, and on the right hand side we have a die. Now what type of shape and size is being given to that die, it depends upon that accordingly when that ram is pushed, the material will be converted to some another form, and because of that the material will be, you can say, converted to that required shape and size. Because of this, the greatest force required is at the beginning of the process and slowly decreases as the billet is pushed up. Now this is the most versatile method that is normally used in the industry for extruding the products. Different things which can be produced are already discussed, like you can have any shape, you can convert a larger billet to smaller level cylinders. Now in this diagram also what we are doing, we are just decreasing the diameter of that material, and we are just convert to a different shape. This is the one method, that is the direct extrusion. Now next one is the indirect extrusion. Now in indirect extrusion, also known as backward extrusion, the billet and container move together. Now you can also see it from this diagram also, that we have a container or a cylinder in which the heated billet metal has been put, and on the right hand side we have seen that a plunger or a ram is there, and that has been pushed, and because of the application of force the extruded metal will be there. Okay, so the in this method the die is held in places by a stem which has to be longer than the container length. The maximum length of the extrusion is usually dictated by the column strength of the stem. Because the billet moves with the container, the frictional forces are eliminated. So in this method it has been seen that uh, the frictional forces are less and the quality of product is high, but its capital cost is more. So sometimes it has been seen that it is very less used in the industry. So extrusion process may be just like you can have a use of toothpaste in the early morning, and when paste comes out of that circular portion, its dye is decreased. So that is a, yes, you can say, a simple example of extrusion process. Then we have cold extrusion process. The cold extrusion is done at room temperature or near the room temperature, and the advantage of this method over the hot extrusion are the lack of oxidation, because the temperature is not there, and because of temperature, when a metal is exposed to some temperature and then this heated material exposed to some environment, then the oxidation will be there. But in cold working, that oxidation problem is not there, and high strength due to cold working. Yes, the cold working method is worldwide used, where the higher tolerances or closer tolerances are required and high strength is required. It also gives the good surface finish to the material and fast extrusion speeds if the metal is subjected to hot shortness. So the materials that are commonly cold extruded include lead, tin, aluminium, copper, zirconium, titanium, molybdenum. So these are some of the different materials that are used or you can say on which the this cold extrusion process can be applied. Normally the material should be ductile in nature, so that will be more comfortable. And under this cold extrusion method, different methods are there like hooker extrusion, hydrostatic extrusion, and impact extrusion. Now this is the first one, that is hydrostatic extrusion. In the hydrostatic extrusion process, the billet is completely surrounded by a pressurized liquid, except where the billet contacts the die. This process can be done hot, warm, or cold. Okay, and the temperature is limited by the stability of the fluid used. The process must be carried out in a sealed cylinder to contain the hydrostatic medium. The fluid can be pressurized two ways. First is the concentrate extrusion, in which a ram or a plunger is used to pressurize the fluid, or the constant pressure extrusion. A pump is used possibly with a pressure intensifier to pressurize the fluid, which is then pumped to the container. So ultimately, if you see this diagram which is shown for the hydrostatic extrusion, you can see that that billet is there, and on this billet we that material is contained by a fluid, and when we apply the force on the right hand side with the ram, this material will be deformed according to the die. But the what is the main advantage of this process is that that uh, the the application, because of the application of the force, the heat will be generated, and that heat, you can say, will not be available for applying some cavities or cracks to the metal. They will be dissipated to the fluid, and the operation is also very smooth. And because of the smoothness of this process, it is very used in the industry. And next is the impact extrusion. Now you can see from this diagram also, in the hooker or extrusion down method, a cup is formed mm, by a suitable working operation. Extrusion then consists of elongating and thinning the walls of the cup using a shouldered punch and die. Okay, and this cold working process is commercially applied mainly for the production of small thin walled copper and aluminum seamless tubes and cartridge cases. You can well understand this method by just seeing this hooker diagram, in which the one ram is there and blank is there, and that blank is placed on the die, and when ram is applying some pressure, the metal will come out as a extruded part, you can say. Now some of the defects, some of the, you can say, defects of extrusion. First is the surface cracking. When the surface of an extruder splits, this is often caused by extruding temperature, friction, or speed being too high. It can also happen at low temperature if the extruded product temporarily sticks to the die. Second defect may be the pipe, a flow pattern that draws the surface oxides and impurities to the center of the product, which is very deleterious for the product. Such a pattern is often caused by high friction or cooling of the outer regions of the billet. Another defect is the internal cracking. When the center of the extrusion develops cracks or voids, these cracks are attributed to a state of hydrostatic tensile stresses at the center line in the deformation zone in the die. And another defect is surface lines. When there are lines visible on the surface of the extruded profile, this depend heavily on the quality of the die production and how well this die is maintained. That is very important, because sometimes it has been seen that die is there but their maintenance is very poor, and because of poor maintenance the product quality normally is not that is required. uh, Now this is another method of manufacturing, that is tube drawing. It is a metal working process to size tube by shrinking a larger diameter tube into smaller one by drying the tube through a die. and this process produces high quality tubing with the precise dimensions, good surface finish and added strength of cold working. Because it is so versatile, tube drying is suitable for large and small scale production both. So now you can see this mechanism easily from the diagram also, that on in first diagram that is marked as A, we have a mandrel sport and we have a mandrel, and that is being put inside that tube, which is again fed to the die, and ultimately with the application of force the tube manufacturing can be there. Now next method of manufacturing is the wire drying. Now wire drying you can say is a metal working process that is used to reduce the cross section of the wire by pulling the wire through a single or a series of different drying dies. There are many applications for wire drying, including electrical wiring, cables, tension loaded structures, springs, paper clips, spokes for wheels, okay, stringent muscular instruments. So all these things can be manufactured by this wire drawing method. This is just similar to, you can say, extrusion process. Although similar in process, drawing is similar from extrusion, somewhat different from extrusion, because in drawing the wire is pulled rather than pushed through the die. Yes, that is the difference. And drying is usually performed at room temperature, thus classified as cold working process, but it may be performed at elevated temperature for larger wire to do forces. So this method can be applicable for larger production of wires. Normally the production of wires are with this method. The main important thing here is the rolling mechanism and the die. If the mechanism is okay and die is okay, then this method is very okay. Next, then last method of manufacturing is the powder metallurgy. Now this is very important route for the production of something, because its quality is high. But is basically done in powder metallurgy is it is a method or process of blending powdered materials, uh, pressing them into a desired shape by compacting method, and then heating the compressed material in a controlled environment or atmosphere to bond the material, that is a sintering process. So ultimately हम करते क्या हैं पाउडर मेटलर्जी में, हम कोई पाउडर लेते हैं किसी भी मेटल का, लाइक हमने एल्यूमिनियम ले लिया या क्रोमियम ले लिया, उसमें कुछ ब्लेंड्स मिक्स कर दिए, जैसी हमें प्रॉपर्टी मटेरियल से चाहिए अकॉर्डिंगली द डिफरेंट मटेरियल्स विल बी एडेड, लाइक we added some aluminum, titanium, some copper, some different metals, and then they will be compacted in a desired shape. Then that compact will be put in an environment where temperature may be there, some gas environment may be there, and because of that heat and because of the availability of that air or that gas, the material will be converted to a solid material, because bonding will be there. Okay, and this powder metallurgy generally consists of 4 basic steps. First is the powder manufacturing. So first thing is the manufacturing of powder, that how you can manufacture it. Second is the powder blending, that how you blend that manufactured powder. Third is the compacting, that is the conversion of material to some required shape. And last is the sintering, that how that material is bonded and properly manufactured to the required shape. A powder manufacturing, any fusible material that can be atomized. Several techniques have been developed which permits large production of rates of powder articles. So different methods are there. So this is just written material, that you want to convert a bulk material to the powder form. Okay, so different powders can be there, like it can be titanium, vanadium, thorium, niobium, uranium, by high temperature reduction of the corresponding nitrides and carbides. तो हमने करना क्या, हमें मेटल चाहिए, पाउडर फॉर्म में चाहिए, अब कैसे भी उसको कन्वर्ट कर सकते हो, या जैसे हम उसकी सिंपल रा मिलिंग कर सकते हैं, हमारे पास ब्लॉक्स हैं बड़े बड़े, उनको हम जैसे हम आटे की चक्की पे जाते हैं, वहाँ पे हम ग्रेन्स देते हैं और आटे में कन्वर्ट कर देते हैं. जस्ट लाइक दैट यू कैन से वी हैव डिफरेंट बॉल मिल्स इन विच दी material is fed in a larger form and that is can be converted. We can convert by some chemical route, like some chemicals may be there that you use to break the larger material to the smaller parts by some method. Then you can have some physical method like physical vapor deposition, in which the material will be physically bombarded by some electrons, by some plasma, some by gas, you can say, so that the um, metal is converted to another form. Some reduction method may be there by reducing metallic oxalates or formates. So different methods can be there. So large number of methods are available in the market by which these powders can be manufactured. Like automation is there. Automation is accomplished by forcing a molten metal stream through an orifice at moderate pressure. A gas is introduced into the metal stream just before it leaves the nozzle, serving to create turbulence as the entrained gas expands and exists into large collection volume. Okay. सो हमें करना क्या है, अल्टीमेटली हम चाहते हैं कि कोई भी मटेरियल जो अवेलेबल है उसे शॉर्ट या स्मॉलर साइज़ में कन्वर्ट करना है, और उस स्मॉलर साइज़ में जो प्रोडक्ट हमें मिल गया है उसको हमने रीयूज़ करना है. ओके, नेक्स्ट मेथड इज द सेंट्रीफ्यूगल डिसइंटीग्रेशन. नाउ इन दिस मेथड आल्सो the extensive experience is available with iron, steel and aluminum. Metal to be powdered is formed into rod which is introduced into a chamber through a rapidly rotating spindle. Opposite the spindle tip is an electrode from which an arc is established which heats the metal rod. As the tip material fuses, the rapid rod rotation throws off tiny metal droplets which solidify before hitting the chamber walls. A circulating gas sweeps particles from the chamber. Similar techniques could be employed in space or on the moon. The chamber wall could be rotated to force new powders uh, into remote collection vessels and the electrode. So this is one method. Now other techniques I have already discussed also, like another methods are also there, so that is you can well understand. Next part of is the powder compacting. Now we have produced the powder, we have blended it with some materials. Now then compaction. Now from this diagram it can be easily understood that it is a process of compacting metal powder in a die through the application of high pressure. Typically the tools are held in a vertical orientation with a punch tool forming the bottom of the cavity. The powder is then compacted into a shape and then ejected from the die cavity. Yes, you can see that this is a very simple operation. We have this compact and a die and a compacting plunger or punch may be there which presses the punch on both sides, and a small shaped compact will be there. After that you can say this compact will be used for further processing. हमें अल्टीमेटली उससे करना क्या है कि जो इससे हमारे पास बल्क